Right, in this video we're going to compare three methods of solving quadratic equations, namely solving by factorizing, the quadratic formula, and completing the square. Before we proceed with the comparison, it's just worth noting that the quadratic formula is actually derived by completing the square. So these two are essentially the same method. It's just that this one is a shortcut of completing the square. So we're going to start by comparing the length that each one will take to enable you to solve an equation. The one that's going to take the longest is going to be the method of completing the square, and the one that's going to take the shortest is going to be the quadratic formula. I've already said the quadratic formula is the shortcut of completing the square. So, and this one is going to be in the middle of the two of them. And then in terms of applicability, the method of completing the square is going to work always. So this works all the time. So long as there is a solution, this method will find it. This one, which is a shortcut of completing the square, is also going to work always. And the method of factorizing is going to work occasionally. So let's just say here, does not work always. We're just going to talk about the conditions when this method works. So the method of factorizing is going to work only works if the discriminant discriminant is b squared minus 4ac. Let's put this line here. So this works if d, which is b squared minus 4ac, if this is equal to a positive, maybe I'm going to have to kill this boundary here, only if this is a positive rational square number. Okay, what do we mean by this? So if d is like 0, 1, 4, 9, 16, etc. So those are square numbers. The rational here means that this could be a quotient of these. So 9 over 4 is going to be a rational square number. 16 over 9 is going to be a rational square number because the numerator and the denominator are square numbers. So we're saying if d is any of these, then your method of completing, so the method of factorizing, is going to work. Actually, there is another video that we have done which just looks at the role of the discriminant if you check that video, it's also going to have the details of how the discriminant works in the different cases. All right, so from this, if the question just says solve a quadratic equation and there's no restriction on which method to use, this is clearly suggesting that the quadratic formula is going to be your best shot. But of course, as a student, question might specify which method to use, so that means you need to master these other two methods as well, because if the question says solve using the method of completing the square, then if you use any other method, of course you will not get any marks for that question. All right, so now what we're going to do is we're going to go through we're going to do some examples where we're going to solve each question using each of these three methods and compare how things work out. All right, so in this set of examples, we are going to solve each equation, and first by factorizing. Maybe we should add here where applicable, because we did mention that in some cases the factorizing method is not going to work. And then in part 2 we're going to use the quadratic formula. So let's rewrite it here. So quadratic formula is x equals to negative b plus or minus b squared minus square root of b squared minus 4ac all over to a. We do have a video that just looks at a detailed application of this method in solving quadratic equations. And then lastly, we're going to use the completing the square approach. All right, so here in the first instance, we are going to attempt to solve this by factorizing. So the thing we are going to do first is to work out the discriminant. So here b is 5 over 3, so all squared. A is 2, c is negative 7. So this is going to be 25 over 9 plus 56. Now the thing we want to do is to express this as a fraction, not as in decimal form, because then we won't be able to see whether this is a square number or not. So I need to write that as one fraction. 56 times 9 is going to be equal to 504. So this is going to be 504 over 9. Then 504 plus 25 is going to be 529 over 9. 9 we know is a square number. The question is 529 a square number? Well, we can test that by plugging it in the square root, and square root of 529 is 23. So that means this is a square number. So this number is 23 over 3 all squared. Okay, all squared. So that tells us that the equation is factorable. Equation is factorable. So we don't start looking for numbers that we can't find in the case, as would be the case where the equation is not factorable. The thing that is recommended at this point is to clear the fractions, so that's what we're going to do. So we're going to multiply everything by 3. Multiply everything by 3, we're going to have 6x squared plus 5x minus 21 equal to 0. So we're going to look for two numbers, m and n, that multiply to give 6 times negative 21, which is negative 126. So it means that the two numbers we are looking for have got opposite signs. Then m plus n, these two numbers add up to give 5. So that means the bigger one is going to be positive, right? Then we are going to show you a systematic way of finding these two numbers. So we're going to start with 1 and 126. So we're going to put the negative here, so we add these two, we're going to get 125. Then 2 goes with if we do 126 divided by 2, we get 63. So 2 goes with 63. This one is negative, so that's going to be 61 there. Then 3 goes into 126 42 times. So we're going to have 3 and 42, negative 3. So this is going to be 39 here. 4 does not go into 126. 5 does not go. 6. So 126 divided by 6 goes 21 times. And then 21 minus 6 is going to be, okay, well, what's 21 minus 6 is 15. 7 shouldn't go into 126. No, actually it does. So negative 7 goes 18 times. 18 minus 7 is 11. Then the next one, let's try 8. 126 divided by 8, that one doesn't go, so 126 now divided by 9, it goes 14 times. So we're going to have negative 9 and 14, and negative 9 minus 14 is 5, which is the same as that. So we've got our two numbers, and so we can factorize this now. So a is 6, so this thing is going to be 6x minus 9 times 6x plus 14 all over 6 is equal to 0. So this tells us that either 6x minus 9 is 0 or 6x plus 14 is 0. So from here it means x is 9 over 6 or 3 over 2, or here x is negative 14 over 6 or negative 7 over 3. So that is the method of factorizing. Then next we're going to do the method of the quadratic formula. So we've got 2x squared plus 5/3 x minus 7 is equal to 0. So from here, a is 2, b is 5/3 and c is -7. So x is going to be negative b is going to be negative 5/3, then plus or minus the square root of b squared minus 4ac. We have already worked out in part 1. It was 529 over 9. And then this is times divided by 2 times a. So this is going to be minus 5/3 plus or minus 23 over 3, all divided by 4. If we take the minus here, it's going to be negative 28 over 12, 3 times 4. If we take the plus here, it's going to be 6 over 4. So negative 28 over 12, negative 7 over 3, 6 over 4 is 3/2, which is exactly the same as the two answers we got. Just note how much shorter this one is. Then in part 3, we're going to do the method of completing the square. So in that method, we said if we've got a quadratic equation like this, first thing we're going to do is we're going to divide by the coefficient of the x squared, so that the coefficient of x squared ends up being 1. So this is going to be x squared. This is going to be 5 over 6. The 7 we take to the other side and divide by 2. Then this we can write as x plus 1/2 of this is going to be 5 over 12, and then all squared. And then this side we're going to add the square of 5 over 12, so it's going to be 25 over 144. So 7 over 2 plus 25 over 144. If we write this as a single fraction, it works out to 529 over 144. We have already seen in part A that 529 is a square number, but also 144 is a square number. So if we take square root on both sides, we're going to have this side plus or minus the square root of 529 over 144. So this is plus or minus 23 over 12. Then if we make x the subject of the formula, it's going to be minus 5 over 12 plus or minus 23 over 12. This is now exactly the same as okay, let's just finish it off. So if we take the minus case, it's going to be minus 28 over 12. If we do the plus case, it's going to be 18 over 12. So that's minus 7 over 3. If we divide that by 4, and the other one is going to be 3 over 2. So that is the method of completing the square. We're going to do one more example before we give you something that you can try yourself. In the second example, we are going to look at 2x squared minus 5x minus 9 is equal to 0. So in the first case, we're first going to check what the value of the discriminant is before we start trying to factorize. So for AC, so this is going to be negative 5 squared minus 4 times 2 times negative 9. That works out to 97. Then we check if 97 is a square number in case we are not sure, and we are going to find that if we check that the decimal formation of it is 9.848. So since that is not an integer, this means that 97 is not a square number, and so the equation is not factorable. Equation is not factorable in this case. So that means the method of factorizing is not going to work. Of course, that doesn't mean that the equation does not have a solution, because the discriminant is positive. This equation will have a solution. It's just that the solution is not going to be a rational number, so that's why the factorizing method is not applicable. Right, so using the quadratic formula, b is negative 5, so negative b is going to be 5. Then we're going to have the square root of b squared minus 4ac, which we already have from here. So we can simply just plug in 97. Then in the denominator, we're going to have 2 times 2. And so we have our solution straight away. So over 4 here. And so we can continue now to the method of completing the square. So similarly to what we did in A, here we're going to have to first divide by 2. So if divide by 2 is going to be minus 5 halves x. The 9 we take to the right hand side. And then we write this as something squared. That something is going to be x minus half of this number here. So it's going to be 5 over 4. Then this side we add the square of 5 over 4 is going to be 25 over 16. Then 9 halves plus 25 over 16 is 97 over 16. Taking the square root on both sides, so this is going to be plus or minus the square root of 97 over 16, which is plus or minus the square root of 97 divided by 4. Then if we take 5 over 4 to the right hand side, this is what we're going to have, over 4. Sorry, this is 5 over 4. And then we can write this as a single fraction, 97 all over 4, which is exactly the same as the answer we got there. Right, at this point we're going to give you 2 that you may want to try. You are going to want to pause the video and have a go at these. So the first one, 5x squared is equals to 4x plus 7, and then this one, 6x squared plus 7x is equals to 3. You just want to pause the video, have a go at these 2, and then when you continue the video, you can compare your answer with our answer. Alright, we're now assuming that you've had a go at these 2 exercises. We are now going to scroll down to our solutions, which you can check against yours. So In C, the first thing we're going to need to do is to bring everything to the same side. Then for the first case, we are going to first work out the discriminant, which in this case works out to 156. Now, square root 156 is not an integer, so there is the decimal formation there, so that straight away tells us that this equation cannot be solved using the factorization method. Then for the quadratic formula, if we plug in negative b, it's going to be 4 because b is negative 4, and plus or minus square root of b squared minus 4ac, which we've already worked out here. And then this said we can simplify because 4, which is a square number, is a factor of 156. So 156 divided by 4 is 39. So it means 156 we can write as 4 times 39. But then square root 4 is 2. So this thing is going to be 4 plus or minus 2 square root 39. And then we can cancel out 2 here. So 2 goes once here, 5 times there, and twice there. And so that's going to be our final answer. And then for the completing the square approach, so we're going to first divide by this coefficient of x squared because it's not 1. So divide everything by 5 and take the constant to the right hand side. And then we write this as a squared term, where this is the half of this term. Then we're going to have to square add the square of this term this side, which is going to be 4 over 25. When you add these two fractions, you get 39 over 25. And then take square roots on both sides. And then finally we can write this as a single fraction, which you're going to notice is exactly the same as that answer there. Then in D, again we first bring everything to the same side. This time the discriminant is 121, which is 11 squared, so the equation is definitely factorable. So we're going to have to look for two numbers that multiply to give 6 times negative 3. So these numbers are going to have opposite signs, and then when you add them you get 7. So these numbers are such that the bigger one is positive. So here you can, because these numbers are fairly manageable, find those numbers are going to be 9 and negative 2. By the way, this sign here this sign here means implies. So that sign means implies. We're using it a lot. So like the fact that this is a square number here implies that the equation is factorable. So we factorize here and equate the two factors to 0, and so we get that the answer is either negative 3 over 2 or 1 over 3. Then for the quadratic formula, we're simply going to take that discriminant and plug it in under the square root there. That's negative b. That's 2 times a. So this is going to work out to negative 18 over 12. It's going to be 4 over 12. So again, it gives us the same two answers that we got there. Notice that this is like hardly 2 lines, so that method is always giving us the shortest we get the result after a few lines. Here we're going to have to divide by 6 first, so that the coefficient of x squared is 1. Then take this the constant term to the right hand side, complete the square here, take the square root, and then this is again giving us the same answers as before. All right,